at time t, the position of an object moving along a line is given by s of t equals t cubed minus 6t squared plus 9t. So t is time, right? That's going to be in seconds, and the position, right, is going to be in meters. So we want to find a couple things. We want to find the object's acceleration each time the velocity is 0. We want to find the object's speed each time the acceleration is 0. And we want to find the total distance traveled by the object between t equals 0 and t equals 2 seconds. Okay. So we know, right, that this is called the position equation, right? We'll call it the S equation, I guess. And we know that the velocity equation, right? The velocity equation is the first derivative of position, right? So let's go ahead and take the first derivative of this guy. We get 3t squared minus 12t plus 9. We also know that the acceleration equation is the derivative of the velocity equation, or the second derivative of position, right? So we get 6t minus 12. Okay, so we've got the position equation, we've got the velocity equation, and we have the acceleration equation. Okay, so we want to find the object's acceleration each time the velocity is 0. Well, when does the velocity equal 0? We just set this guy equal to 0 here, right? I'll just do this work on the side. So we want to find, right, the time when the velocity is equal to 0. Well, in this case, let me just factor out the 3. That should make my problem a little bit easier to deal with. Oh, there should be a plus here, right? Okay. So really, I don't need to worry about that. We get t minus 3, t minus 1 equals 0. So what do we get? We get t equals 3 and t equals 1. What does that mean? It means at 3 seconds, the velocity is 0, right? Remember, we set the velocity equation equal to 0 here. So at 3 seconds, velocity is 0. And at 1 second, the velocity is 0. So we can answer this first question, right? We want to find the acceleration when the velocity is 0. So to answer that part, we'll just find a of 1. Right? We'll plug the 1 in here, we get negative 6. That's going to be meters per second squared. And at 3 seconds, the acceleration is going to be 18 minus 12, which is positive, right? Positive 6 meters per second squared. Okay. We want to find the object's speed each time the acceleration is 0. Okay, here's acceleration, so we're going to set that equation equal to 0, and we get t equals 2. So what does that mean? At 2 seconds, the acceleration is 0, which means it's not speeding up or slowing down. Okay, but we want to find the speed when the acceleration is 0. That's the absolute value of velocity, right? So let's find that. What is v of 2? Okay, so v of 2, we can plug it into either one of these guys, right? It doesn't really matter. Okay, so I'll get 3, plug 2 in here, I get negative 1, plug 2 in here, I get positive 1, I get negative 3. But remember, this is velocity, right? The velocity is negative 3 meters per second. The speed is the absolute value of the velocity, so the speed is going to be just positive 3 meters per second. And the last thing, we want to find the total distance traveled by the object from t equals 0 to t equals 2. So what we want to do is we want to find at t equals 0, okay, the position is 0, right? We're just going to plug in that, okay, s of 0, I guess. What is t equals 1, right? At t equals 1, s of 1 is equal to 1 minus 6, which is negative 5, plus 9, which is 4. It has traveled 4 meters, right? And then what about at t equals 2? Okay, at t equals 2, s of 2, we'll plug that guy in here, right? 8 minus 24, we get 8 minus 24 plus 9, plus 18, right? That equals 2 meters, okay? So what's the total distance traveled then, right? 0 plus 4 plus 2, so the total distance traveled would be 6 meters.